everybody, this is Miss Bufford, and in this video we're going to talk about Lewis dot diagrams. So your learning goals are to be able to identify an element's group from the Lewis dot structures, to be able to give the Lewis dot structures if given the name or the group of the element, and be able to explain the pattern and meaning of Lewis dot structures. So in order to begin talking about Lewis dot diagrams, we have to understand what valence electrons are. These are the electrons in the outermost energy level of an atom, so the energy level that is farthest away from the nucleus. For main group elements, these are going to be the electrons in the highest energy level s and p orbitals. And not every element is going to have electrons in its outermost p orbital. Sometimes they only have s orbital electrons, and that's okay. But if there are s and p orbitals in that outer energy level, then they're all valence electrons. Valence electrons are the most important electrons an atom has because they're the ones that dictate the chemical properties of that atom by participating in chemical reactions. And the number of valence electrons an atom of a main group element has can be determined by looking at the group number. And these are the numbers above the columns on the periodic table, and we'll talk more about those again in just a minute. But remember that this only works for atoms of main group elements, and those are the two towers of elements on either side of the periodic table, and we'll take a look at that here on the next slide as well. But the reason it doesn't work for the F or D block elements is because they have more complicated electron configurations and their numbers of valence electrons can vary, so they're not always the same. And so they're not as predictable as the main group elements are as far as chemical reactivity goes. So Lewis dot diagrams show only the valence electrons that an atom has. And since atoms of the same group or in the same column on the periodic table have the same numbers of valence electrons, their Lewis dot diagrams are going to be the same as far as how many electrons they have shown around them. And there's a very specific way to draw these, and we're going to talk about that on the next slide. But before we do, I just wanted to point out, so on our periodic table in class, the columns are numbered 1A, 2A, 3A, 4, 5, 6, 7, 8A. Okay, so those are the numbers that are going to tell you how many valence electrons the atoms in that column have. And you'll notice for group 1A, they all have one valence electron. Group 2A, they all have two. Group 3A is 3. Group 4A has 4. 5A has 5. 6A has 6. 7A has 7. And 8A has 8 valence electrons. The only exception here is helium. And helium has 2 valence electrons because it only has a first energy level. It doesn't have enough space around it or enough pull to have any more than 2 electrons. And so that's considered full and an exception to that rule for the valence electrons. So always remember helium just has 2 valence electrons. All right, so when we draw Lewis dot diagrams, I kind of showed you this a little bit in the video that we were drawing Bohr diagrams in, but you want to draw the dots around your element symbol in a very specific manner, and I'll explain why when we're done drawing this example here. So you're going to want to follow these steps. So you're going to begin with the element symbol, and in this case, we're going to go ahead and use oxygen for our example. So there's my O for oxygen. And then we're going to choose a starting location, and you can begin on any side you like, top, bottom, left, or right, but you want to put a dot in that location. And before I put my electron on there, I just wanted to kind of point out that if you draw this imaginary box around your element symbol, you can see that there are 4 different locations that we can put electrons in. All right, so here's my first electron. And oxygen has a total of 6 valence electrons because it's in group 6A. And then to do the rest of the electrons, I'm going to choose either to go counterclockwise or clockwise until I've given each electron a location. And so if you're going to choose clockwise, you want to stick with clockwise the whole way around until you run out of electrons. And the same goes if you choose counterclockwise. Whichever way you choose is fine. You just want to keep it consistent the whole time. All right, so I'm going to go ahead and put all 6 of my valence electrons on there. So once I have filled up each side, or once I have put at least one electron on each side, then I can start doubling them up. All right. And since these valence electrons are the ones that participate in chemical reactions, for main group elements, these are only located in those s and p orbitals. So what we've just done is we've filled those outermost s and p orbitals, showing where chemical bonding can occur. And this only occurs in half-filled orbitals. So we're going to talk more about this in Unit 7. So what I mean here is, if you remember, our s orbital is this red one. There's only one s orbital in any energy level, and it can only hold up to 2 electrons. But there can be up to 3 p orbitals, and each of those can hold up to 2 electrons. And later in Unit 7, when we start talking about chemical bonding, you'll be able to see that right here at these half-filled orbitals is where oxygen is able to form chemical bonds. You don't have to know that all right now. You just have to be able to draw the Lewis dot diagrams and recognize, how many valence electrons an element has based on its group number on the periodic table. But it's good to be aware of why these structures are important and why it's important to draw them a certain way, so that later this information is going to be handy. If you have any questions, please go ahead and write them down, and we can talk about them in class. Thank you for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.